Hey, what's up guys? Welcome back to another video in the Spigot series. In this episode, I'm going to give you a formal introduction to packets and how to use them and work with them using ProtocolLib. Okay, so finally I have a packet video, an official packet video. I had a stream in the past where I showed how to use packets, and I had some other people on my channel in the series show how to do packets. But it's about time that I show you, in my own words, how packets work and how to use them and work with them. So I'm going to be starting using ProtocolLib. It's a great library for working with packets. And then in the next episodes, I'll be showing you how to do packets, more stuff with ProtocolLib, and then finally I'll be showing you how to do packets with NMS. ProtocolLib is preferable just because it's easier to work with. Just the library that is built upon it is it's an abstraction over NMS, and it's much easier to use than NMS. And also, the most important thing is that it's cross-version compatible. As you can see here, the tested Minecraft versions for ProtocolLib is 1.8 through the latest version, which means that your packets theoretically should work through those versions. You're going to experience issues probably just because, certain packets are only available in certain versions, and the packets change over time, but there's ways to avoid that. There's like safety methods you can use. But anyway, I'm just going to show you the basics in this episode, and then from there we're going to branch out and learn more about packets in the next episodes. So hopefully you're excited for that. NMS itself is not really cross-version compatible on its own, just because when you import NMS into your project, you have to import a certain version for a specific server version. And when you do that, this means that the code will not work on different versions of Minecraft. If you try running, let's say that you bring in NMS 1.17 for a 1.17 server, and you try using it on a 1.15 server, it just won't work. Even though theoretically the packets you're using haven't changed between those two versions, it still won't work just because of the way that NMS works. So there's ways to avoid that using reflection and abstraction and different techniques to make your NMS code cross-version compatible. And we're going to learn all about that stuff. We're going to dive into that. But generally speaking, ProtocolLib is the best way to do it, best way to get started, and it's great. So we're going to use that. So what are packets? That's the essential question we have to start with. Packets are essentially chunks of information sent between the client and the server and the server and the clients. They're just a way for the server, the Minecraft server, and the client, aka someone's video game, like the game application, can communicate with each other. They have to stay in sync, right? So let's say that a player moves on the server, right? I run around and stuff like that. There's no way for the server to know, that you're running around if you don't tell it, right? So every time you move, a movement packet or a position packet is being sent from your Minecraft game to the server, so that the server keeps track of where every single player is, and it also knows how to show where other players are. The reason that I can see this guy moving right here is because a position packet was sent from his computer to the server, and therefore the server tells me where he is and displays it on the screen. So the idea of the server and the client staying in sync is very important because that's how everything just comes together. Now, the way that this is done is very important. It's done over TCP, which is a networking communication protocol, and TCP stands for Transmission Control Protocol. And essentially, packets are sent on that protocol, from one destination to another. So you can think of the client and the server as its own little network. And a packet, like I said, is just a chunk of information made up of bytes that, is sent from one destination to another. That's all you have to think about when you think about a packet. It's just a chunk of information. And then with that idea, you have different states. So you have handshaking, you have status packets, you have login packets, you have play packets. These are all different states of the Minecraft game. So when you're logging in, I believe the way it works is you're going to send a handshake to a server, and then after that is done, it's going to go to the login state, so that you log into the server. It's going to do some of these packets here. So login success, you can imagine, is sent, from the server to the client to tell them that they can log in, everything works correctly, they can log in. And then we have a server bound packet. So from the client to the server, login start. So you can imagine that this packet is sent when a player tries to log in to a server. It's the first step probably. But yeah, so the most important packets that we're going to be working with, though, are the play packets. These are the packets associated with the main gameplay of the game. So you have all these different types of packets here that are play packets. You have boss bar, server difficulty, set slot, set cooldown, explosion, entity status, disconnect, update light particle. You have everything under the sun, right? And these are split into two different sections. You have client-bound packets, which means that it's heading from the server to the client. And then you have server-bound packets, which means it's heading from the client to the server. So like I said before, a player position packet. So the way that the server knows where a player is because a player position packet is sent from the client to the server. Hence, it's a server-bound packet. And then there's other ones that make sense for client-bound packets. So let's say that an explosion happens on the server. The way that your Minecraft game knows to show that explosion and to affect your player movement is by using the explosion packet. This is sent from the server to the client. So when you do an explosion, the server tells the client that an explosion has happened, and then certain stuff happens. So it shows an explosion particle and all that. So this is just essentially how they stay in sync with each other. This is how they communicate. It's all about packets. Packets are very, very powerful. And this website here, this wiki.vg/protocol, is very, very essential for packets. This is basically your packet Bible. This is how you will know everything about every single packet that is tracked by Minecraft at the moment. It stays up to date too. So I'll have a link for this in the description below. You need to save this so that when you're working with packets, you can come here and you can see how to use packets. I'm going to show you how to read this. It's very tricky on your first try when you're first learning packets to understand how this works, because if you click one of these, you have these weird tables here which don't make a lot of sense when you first look at them, and it's really, really quite intimidating. But I'll give you a basic understanding of how to read them and how to work with them. Don't worry about that. Okay, so this is your packet reference. Save this. And then also you have ProtocolLib, which is the library you will be using to send packets, listen for packets, manipulate packets, all that stuff, okay? So what we're going to do first is go ahead and import this into our Minecraft plugin. So we're going to copy this repository here, go to our pom.xml, and put it in the repository section. And then go back, go to the dependency, and the latest version is 4.7.0. So we're going to import that into our project. Great. Okay, so now we should be able to use ProtocolLib as a library within our project. So what we need to do now is go to source, main, resources, plugin.yml, and add that as a dependency. So depend ProtocolLib. So this is our dependency that our project will be using right here, ProtocolLib. Great, so once we go back here, we can see a bunch of information. You can look through this if you want to. But a really important resource that you'll probably need is right here. So for developers, it says that there is a somewhat dated tutorial that you can find here. This is pretty useful for basic stuff, how to do certain stuff. But you also have another one, a newer tutorial here, which you can use. It's very basic, but it gets you started basically. So it shows you how to import it, which I just showed you, common errors, packet listeners and adapters, packet containers, protocol manager, all that stuff. So look through this if you want to have some other information on how to use ProtocolLib, but I'll be showing you how to do all of this in the video today, so don't worry about that. And then in the future episodes, I'll be showing you some more advanced stuff with packets. All right, so let's get started here. Let's see what we can do with packets. The first thing that we're going to do is do something called packet listening. We're going to listen for packets. So it's the same concept like when you're listening for events, event listeners that you would create within your plugins. You're simply running a piece of code when an event is triggered and you're listening for it, right? The same concept works here. So what we can do is listen for packets that are either received by the server or sent out from the server. You have to think about it this way. Because ProtocolLib is like a library in a plugin that runs on the server, it can only listen for packets on the server. It can't listen for packets on your Minecraft client, right? So you can listen for incoming packets, which means that a packet is heading from the client to the server. It's being received on the server. And then you can also listen for outgoing packets, which means that the server is sending out a packet to the client. And again, the client is simply your Minecraft game, an individual player on the server. Now let's go ahead and start with an incoming packet. So listening to an incoming packet from the client to the server. So to work with packet listeners, we need to obtain a protocol manager. Protocol manager is equal to protocol library .get protocol manager. So this is directly from the ProtocolLib library, or API, whatever you want to call it. So we're going to do manager dot add packet listener, and packet listener requires a packet listener object. But if you try doing packet listener you can see that packet listener is actually an interface. So what we want to create is a packet adapter, which is a abstract class. So new packet adapter, and we're going to override the onPacket receiving method here. There we go. So now inside of here, we provide some information about the packet that we're listening for, as well as the instance of the plugin. So we'll do that in a second. But look closely here. The reason that we overrid the onPacket receiving method is because we're listening to an incoming packet, like I said before. So we're receiving the packet on the server. So this is why that method is onPacket receiving. If you want to listen for an outgoing packet, aka the server is sending a packet to the client, then you would obviously override a different method, aka onPacket sending, which we're going to show next. So the constructor of this abstract class requires some information. We need first an instance of the plugin. We can just pass in this since we're already in the plugin instance. And then now we need a listener priority. You can look more into listener priorities, but essentially this speaks for itself. It's just the priority of the packet that you're listening for. And we're just going to do the normal priority. So listener priority normal. So we don't really need to work with that. So the next thing is the packet type. We're going to use this one down here. So the packet type, we can listen for multiple packet types, which is interesting. But we're going to listen for a specific packet type. So packet type dot play. So you have play packets, like I said before. If we go back to our reference here, we have all these different states of different types of packets. We have play packets, we have login packets, we have handshake packets, all those things, right? So we're going to do a play packet because these are the main packets that we're going to work with for the gameplay on our server. So packet type play, and then under that you have either a client or a server. So the client one is going to be if it's sent from the client to the server, and it's going to be server if it's sent from the server to the client. In this case, we're listening for an incoming packet, so it makes sense to select client because it's a incoming packet, so it's sent from the client to the server. So that may be a little confusing. You may not know which one to select, but again, it's client if it's sent from the client to the server, and then it's server if it's sent from the server to client. So it's the origin of where the packet comes from, originates. Okay, and then after that, you actually just specify the packet itself. Okay, and these usually correspond with the names available on the wiki, the packet reference wiki. Okay, so let's say that we want to listen for a position packet. That's one of the most basic packets you can listen for. So we're going to find position from here. Position. There we go, position, and then you have position look. So let's head to our wiki to see what these mean, okay? So if we go down here, and we're working with a incoming packet, so this will be down here on server bound section, and we want to find player position. There we go. So player position, it says updates the player's XYZ position on the server, checks for moving too fast is achieved like this. So this just gives you basic information on how the server determines if a player moves too fast. And the most important thing here is the packet layout. This, tells you the makeup of the packet, the actual data that you need to fill in for the packet before sending it. This is like the data of the packet itself. So since we're listening for a packet though, we don't need to fill any of this information in. We can extract it from the packet itself. So when we receive this position packet, it's going to come, and we can use this table here to see how to grab the information. And it's very tricky, like I said, but we're gonna figure this out, okay? So we're gonna move this over here, and we're gonna do client.position. So now with luck, this method here, this block of code should be triggered and run whenever a position packet is received from the client to the server. And we can use this event here that is passed in to obtain some information, including the packet itself. So first, let's get an instance of the packet itself. So we can do that with a packet container. So packet container, import that. Packet is equal to event.getPacket. So if you do get packet from event, you can see that it returns a packet container. So that's how you know that. That's why you need a packet container. So there we go, packet container. And so other information we can grab is the event.getPlayer. So you can get the player associated with the packet, get the packet type, network marker, some other information. But usually the packet and the player itself are the most important things that we'll need. Let's go also just store the player in a variable. So player p is equal to event.getPlayer. Import player, there we go. So now how do we extract information, extracting information from the packet? So essentially we want to read the packet, right? So this table shows us how to read the packet. So we have some basic information like the packet ID. Every packet has a packet ID so that you know what the packet is. But that's abstracted into ProtocolLib. But ProtocolLib, makes it so you don't have to worry about the packet ID. You just have packet types. So we have the state. So this is a play packet. You have a bound to, meaning that it's headed to the server. So it's from the client to the server. And then you have the field name, which is like how you know what you're trying to access. So in this case, since it's a position packet, the information that we have stored within that packet makes sense to be the X, Y, and Z coordinates of the player. And also we have another field here, on ground. It's a Boolean that tells you if the player is on the ground or not. So that's cool information. But the most important ones here are the X, Y, Z values of the coordinates of the player. So the field name is what it is, and the notes tells you like specifically what it is. So it's the absolute position of the X coordinate. Feet Y, absolute feet position, normally head, Y minus 1.62. Z is the double absolute position. So the field types here, the data types are most important because you're going to use these to access each of these fields here. So since we know that the X, Y, and Z are doubles, and the last one, the on ground field, is a Boolean, we can use that to access this packet. Let me show you how. So let's try extracting the XYZ coordinates from that packet. So we're going to make variables for that. So double X is equal to blah, blah, blah. Double Y is equal to blah, blah, blah. Double Z is equal to blah, blah, blah. And then Boolean is on ground. Okay, so to access these, we can look at the table again. So we'll go back. So player position. Since the X field here is the first double in this table for the packet data, this means that the index of the X field will be 0. So we can access it by doing packet.getDoubles.read 0. So this will return the first double in the packet from the packet data. So since the Y is the second double, this means that the index of the Y will be 1, and since the Z is the third double, this means that the index of the Z will be 2. It's 0 based, just like an array. So we'll keep working with that. So packet.getDoubles.read 1 for the Y, packet.getDoubles.read 2 for the Z. Now for the last one, for the isOnGround Boolean, if we go back to the table, we can see that this is the first Boolean in our data table here. So to access this, we would get the Booleans, and this would be the 0 Boolean, the first Boolean. The index of this would be 0 because it's the first Boolean. So we'll go back here and we'll do packet.getBooleans.read 0. So since it's the first Boolean, you just access it with 0 based. And that's really the tough part for reading packets and working with packet data. You have to, be able to read the table and then know how to grab it and also set it using the read method here and know the index of what you're trying to set and read. In this case, we're just reading, and we're going to get plenty of practice working with packets in this tutorial. We're going to do a bunch of different examples here. So since we have this information now extracted from our packet that we have received in the packet listener, let's go ahead and send the player a message just, verifying this information here, telling them that we have received the packet. So we can do inbound packet. We can say X, Y, Z, and then finally we'll send them another message on the second line here and say on ground, and then we'll print out the isOnGround Boolean. Let me just recap here what's happening just before we test it out. So we're creating a new packet listener here using the protocol manager, and it requires a new packet adapter. This packet adapter is essentially an abstract class that you instantiate on the fly. Define one of the methods inside of it. If it's receiving a packet, if you want to listen for a receiving packet, aka it's heading from the client to the server, then you override the onPacket receiving method. And if it's, a packet from the server to the client, then you would do onPacket sending, which we'll see in a second. And then you provide other information to the constructor of the packet adapter class, the plugin instance, the listener priority, and then the actual packet type. So to determine the packet type, you just do packet type, and then the type of the state of the packet, which is a play packet, so for main gameplay stuff. And then for client or server, you just specify it by its origin. So since this is a packet that originates from the client to the server, it's a client type of play packet. And then after that, you specify the packet name itself. So in this case, it's a position packet. So this would correspond with the packet ID you find on the documentation here. So packet ID is 0x11. I believe that's hexadecimal if I'm not mistaken. And yeah, so we don't even have to worry about packet IDs. This abstracts it for us, so we can just associate them by their names here, okay? Oh yeah, one thing we did forget to do is you cannot forget this. In your pom.xml, under on the ProtocolLib dependency, go to here and then do scope and set the scope to provided. If you don't do this, then it won't work. You have to do this. So it'll make it not shaded in, I think. Because I was having a lot of trouble with this the other day when I was trying to figure this out. So once I added this, it actually fixed the issue. So if you have any issues where you can't obtain a protocol manager, it's because you did not change the scope to provided. That's probably why. We got our plugin here in the server now in our plugins folder. We also need our ProtocolLib dependency from ProtocolLib. So we'll go back here and click download. And you have to use this, and you have to install this for any plugin that uses ProtocolLib. Okay, so keep. And then we're just going to drag and drop that into our server as a plugin. There we go. Boom. So hopefully now our plugin should be able to hook into ProtocolLib, and ProtocolLib should take any incoming position packets and route it to our plugin to listen for it and run some code, okay? So let's go ahead and start the server and see what happens. All right, I'm on the server and look at what we got here. We're being spammed with a bunch of messages, which says incoming packet, X, Y, Z, and then it says on ground, true or false. So if you run around here, you can see that it's changing because the server is receiving new packets every time I move, essentially. So every time I move, my Minecraft game is sending a packet from here to the server, and this is how the server knows where I am, and it's going to use that to tell other players on the server where I am, so they know how to see me, essentially. Now let's make a new listener so we can listen for outgoing packets from the server to the client. So let's make a new packet listener. So manager.add packet listener, new packet adapter, and this time we're going to choose on packet sending since we're sending a packet this time from the server. So we're going to do this since we're in the plugin instance, packet type, our listener priority. Oh yeah, we don't even need a listener priority since we can just use this one here. So okay, we'll do that. So packet type dot play dot server, since it's an outgoing packet, so from the server to the client, so server is the origin. And then the packet type, we're going to do relative or rel underscore entity underscore move. Okay, and if we look on the documentation here, let's see if we can find this one. Let's go up to here. Now we need to go to client bound packets since it's headed to the client. And the one that I'm working with is entity position. So it's kind of similar to the position packet for a player, but it's actually different because this one is only sent when an entity moves less than 8 blocks. And then the data that it sends is not the coordinate of the new coordinates of the entity. It's the position, the change in position. So let's say that it moves, a couple blocks in the X direction, then it's going to be a delta X of 2 blocks, 3 blocks, whatever. It's just the change in X, change in Y, and change in Z. And then you have some other information like is it on the ground, and also the entity ID, so you know what entity was moved, and you can grab it too with the entity ID. So even though it's not called the same thing as it's called within ProtocolLib, it's called relative entity move. You just kind of have to play around with it and use common sense to determine which one it is. In this case, this is entity position. All right, so let's go ahead and use that one. So when we receive the packet, we want to get a new packet. We want to put that into a packet container. So packet container packet is equal to event.getPacket. So now we can extract data from this packet. Let's keep it simple and first extract the XYZ change, the delta XYZ, so we know how much they moved. So this will be, these are shorts. So this means that we're going to grab the first short, the second short, and the third short. And then the Boolean will be the same as the first Boolean and the only Boolean. And then we'll grab the entity ID after that. So let's get the XYZ first. So it'll be short, so X is equal to packet dot get shorts dot read 0. So the first short is an X, so short Z, Y, excuse me, is packet dot get shorts read 1. short z is equal to packet dot get shorts read 2. All right, and then let's also get is it on the ground or not. So we'll not get that one. We're just gonna grab only these. You don't have to grab all of them. You can do whatever you want, and you can grab whatever information you want. Now let's go ahead and grab the entity ID. So if you remember on the table here, an entity ID is the field type is a var int. This is like a special type of integer. It's actually documented up here at the top. It tells you information about what it is and how to grab it and work with it. So var int and var long. It says these are variable length formats such that smaller numbers use fewer bytes. Blah, blah, blah. And then it gives you some pseudocode for how to work with it for reading and writing. But this is already abstracted into ProtocolLib, so you don't even have to worry about that. You can just grab them as regular integers. So let's go back to the packet. So this will be the first var int. So we can just think of this as the first integer. That'll be the entity ID. So we're going to do integer entity ID is equal to packet dot get integers dot read 0, since it's the first one. Now, what are we going to do with this information? Let's go ahead and print it out just so we can see it, just like we did last time. And let me go ahead and copy these. Copy this one here, and then comment it out, because we don't want to be spammed with that. Let's just print that out here now. We're going to need an instance of the player. So player p is equal to event dot get player. Okay, so now it's gonna message a player every time we receive a new, or every time we send a new outgoing entity move packet. So it's gonna send the player the change in the x, y, and z. And we're gonna leave the entity ID alone for now, but we do have it in case we need it. So let's go ahead and test this out on the server. There we go. So now we get inbound packets. Oh wait, we need to change the message. It's actually an outgoing packet now. We didn't change it, so this would be an outgoing. Cool. So now we can see every time an entity move packet comes out from the server to the client, it's listened by ProtocolLib and then routed to our plugin. So our plugin is printing out all of that each time. So it's a lot of entities on the server, as you can imagine. So it's spamming it a lot. Now, as you can imagine, the entity ID is kind of powerful. We can use that to get the entity that has moved. And so let's see what we can do with that. So if we go back here, we can actually use a method built into ProtocolLib that takes the entity ID and returns a bucket entity object so that we can work with it, which is pretty cool and very useful. So entity is equal to manager dot get entity from ID. So this method will take a world and also the entity ID itself and return an entity object. So this entity can be anything. A player is an entity, a mob is an entity, an animal, a bunch of things. So the possibilities for this are quite large. And this is only listening for packets right now. Once we get to manufacturing our own packets from scratch, this is where packets get really powerful, because listening for packets is very powerful too. You can cancel packets, you can manipulate them and stuff like that. But actually making our own packets and sending them is very, very powerful for doing some cool stuff. So we're going to do that later. So entity is equal to manager.getEntity from ID. So first we need the world. So we're going to do p.getWorld. That's the easiest way to get a world. And the entity ID. There we go. So now we're going to take this entity and teleport it to the player. So how about entity.teleport p.getLocation. So hopefully it's going to take the entity that was moving before, that's why the packet was sent, and then teleport it to the player. So we should get like every entity near the player teleported. So that'll be kind of cool. It's going to be crazy. So let's see what happens. Okay, so let's do /reload and watch what happens. Look at, oh my God, look at that. We just get every mob teleported at us and we just die instantly. So let's see if we can hurry up and change the game mode creative. So game mode creative. Yes, we made it. Okay, look at this. Every mob on the server that is moving and the packet is being sent for it is being teleported to us. So I was thinking about this last night. This could be like a black hole type of plugin, like a prank plugin maybe, a feature called black hole. So everything around you just gets sucks like into your presence, I guess. So pretty cool. I'm seeing mobs that I didn't even know existed. I think these are fish actually. Okay, I'm going to show you now one more packet listener. Just so we can see how we can cancel a packet to achieve some sort of functionality on our server, our plugin, because canceling packets can be something cool that you can do to achieve certain things for your plugins. Anyway, let's go ahead. That's kind of a vague statement, so let me just go ahead and show you. So we're going to make a new packet listener. So manager.add packet listener, new packet adapter. And this one's going to be a receiving packet, so a packet from the client to the server. Okay. And again, just think of this as the server's perspective. Since ProtocolLib is on the server, it can only listen for packets like directly being received by the server and also being sent from the server to the client. It's not on the client, so it can't listen at that place. All right, so we'll need an instance of this, and then the packet type dot play dot client. So from the client to the server dot, and we're gonna do chat. So this will be a chat packet. And let's go ahead and look at the documentation real quick to see some more information about a chat packet. So it's server bound. So we'll go to the section server bound, and we'll look for the chat packet. Chat. There we go, chat message. I think this is it. So used to send a chat message to the server. This message may not be longer than 256 characters, or else the server will kick the client. If the message starts with a slash, the server will attempt to interpret it as a command. Otherwise, the server will broadcast the same chat message to all players on the server, including the player. Prepending with player's name. Specifically, it will respond with a chat translate blah 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 blah. So information about the chat packet, and then the information you can grab from that is obviously going to be the message, which is a string, which is a limit of 256 characters. The note says the client sends the raw input, not a chat component. Okay, cool. So that's the basics of a chat packet. What we want to do is cancel the packet so that we can prevent players from being able to talk on the server. So essentially, if you want to make some sort of muting plugin, this is one way you could do it. You could just literally cancel the packet from ever being received on the server. So that's one way to stop other players from seeing what you type. Okay. So we're going to do event.setCanceled true. So like basically just how you can cancel, just like how you can cancel regular bucket events, you can also cancel packet events. Okay, so let's go ahead and try this out. Okay, now let's try, well, first of all, this is spamming us, but let's try this out. As you can see, when I type, nothing happens. It's not because it's spam, it's just because the chat packet is being canceled itself, so it never shows anything in the chat, because as the documentation said, it also broadcasts it to you. So even though you send something, and you're not going to see it yourself unless the packet is received by the server. In this case, it's not received by the server because we're canceling the inbound packet event. All right, so that's one way you can cancel inbound packets. That's pretty cool. You can also cancel outgoing packets, of course, so you can cancel clients on the server from being able to receive certain critical information. So that's the basics for listening for packets. You know how to listen to incoming packets, so packets heading from the client to the server, how to grab information from those packets, extract the data, and also how to listen for packets headed from the server to the client and do the same thing, extract the data. Also, you know how to get an entity from a entity ID extracted from the data, which is a cool utility provided by ProtocolLib. And then finally, I showed you how to cancel packets. So you can cancel packets from ever being received by the server, which gives you some really cool functionality. Now I'm going to show you how to manufacture your own packets, which is a very, very powerful thing you can do to add some awesome stuff to your plugin. So you can make stuff happen that would not naturally happen within the Minecraft game. So for example, if you were to send an explosion packet from the server to the client, then you can make it as if an explosion happened for people when it really didn't. And if you want, you can selectively send packets to certain players. So if you don't want all players on the server to receive a packet, you can send that packet to a specific player so only they receive it. So only you can create visual experiences for players, for specific players, which is really powerful too. So if you only want that one player to receive a explosion packet, then they will only see the explosion, not anyone else, and they will only be affected by the explosion, not anyone else. So let's go ahead and see how we can do that. Let's make an explosion packet. That's a really good example packet. So we're going to make a new boom command. So this will be a simple command that when we look at a block, it makes the block have an explosion. It basically makes the block explode. The block itself won't be deleted, but it'll have an explosion at that location. So we're going to do implements command executor. So one way that you can get the block that a player is looking at is by doing p.get a line of sight. And basically it's going to return a list of blocks that represents all of the blocks in that player's line of sight. So that's going to include the air. It's going to include the block that they're looking at. So if you're looking at, let's say that you're looking at from here to that sand block, then it's going to give you all the air blocks, and also it's going to give you that sand block. So what we want to do is get the location of that sand block that they're looking at, and then spawn a packet, basically make a new explosion packet that targets that location, so the explosion will appear at that location. The first parameter is how you specify what materials count as transparent materials, so essentially to be ignored. And if you set it to null, then it'll only be the air blocks. So we'll have like default looking functionality, so the air blocks will be ignored, and we'll only get, you know, the other blocks, the solid blocks essentially, hopefully. And so the max distance will do 50 blocks, and then we're going to stream that because it returns a list of materials, right, or a list of blocks. So we're going to stream that because lists are streamable, and so we're going to filter out. It still gives you all of the air blocks, excuse me, I misspoke. It's still going to give you all of the air blocks, so we're going to filter out each of those air blocks. So we're going to do block, if block dot get type is equal to material dot air. Then we want to return false. Otherwise, return true. So we only want to have the other blocks that are not air within this, and we can simplify this, of course. There we go. So finally, once we have all of the solid blocks, this last block should be the one that you're looking at, hopefully. So what we want to do is for each of those, theoretically it's only going to be one, hopefully, but it's still a list. So for each of these, we want to get the location of that block. So location, block location is equal to block.get location. And make sure you import location. There we go. And now we want to create a new packet. So to create a new packet, first we're going to need our protocol manager, just like we did for our listeners. So protocol manager is equal to protocol library.get protocol manager. So now we can create a new packet from scratch. So before in our listeners, we grabbed the packet from the event. In this case, since we're creating a packet, we're going to create a new packet, not grab it. So we're going to do packet container, because that's how you have a packet, is equal to manager.createPacket. Now the packet type is going to be the same packet type, the same way that you found the packet type for the listeners. This you specify it the exact same way. So packet type dot play, it's a play packet, and this will be explosion packet, which let's go ahead and pull up the documentation so we can see firsthand what they are. So let's go back up here. So I know for a fact already that a explosion packet is going to be a client-bound packet, because this is how a server tells a client that an explosion has happened. And this one has a lot more information. So it says, since when an explosion occurs, creepers, TNT, and gas fireballs. And you don't have to fill in all of the information here. You can selectively fill in certain information. So first we have here the XYZ coordinates of where the location of the explosion is going to occur. And then we have some other stuff like the strength of the explosion. It says a strength greater than 2.0 spawns a different particle, while lesser strength spawns a other particle. Okay, kind of cool. And then finally, we're going to ignore these two in the middle. We don't really need to touch these at all. But at the end here, we have the player motion packets, the data fields, which specify the velocities of the player in each of the coordinate planes when they experience the explosion. So this is how we can edit how the player is affected when the explosion happens to them. And we can play with these in a second, but first let's set up the explosion itself by setting the coordinates for it. So this one's a little, annoying because it does say XYZ, which it says float for each of these, but it's actually a double type. And I guess it's something you just have to figure out on your own. But yeah, you do have to use a double just because XYZ coordinates are double types. So if we go back here, we can do, well, first of all, we need to specify the packet type still. So we'll do packet type.play dot client, or rather server, since it's headed to the client, and then explosion. There we go. And then we can set the data. So packet dot get doubles dot write. In this case, it's not read, it's write, since we're putting data. So write, the first field, it's going to be the first double. So the first double, or in this case, it says it's a float, but it's a double. So it'll be the first one. So it's going to be 0, 1, 2. Okay, simple enough. So 0, block location, dot get x, packet, dot get doubles, dot write, field 1, block location, dot get y, packet, dot get doubles, dot write, 2, block location dot get z. So those hopefully will set the XYZ data fields for the packet. So the explosion should occur at that XYZ coordinate point. So after that, once we set the data for the packet, we can try sending the packet using the manager. So we'll do manager dot, and you have two different options for sending packets. You can either broadcast the packet, which means that every person on the server is going to receive it, or you can send it to a specific player. So manager.send server packet. So the player receiver is the person who's going to receive the packet, the client, and then the packet container is the packet itself. So you can do broadcast if you want to, but we're just going to go ahead and do the specific player packet sender. So we're going to pass in the player, so P, and then the packet container, the packet, and we don't need any of the extra data here. We can leave that alone. There we go. So hopefully that'll send the packet. We do need to handle this exception though, a reflection invocation target exception. There we go. And let's go ahead and register our command now since we're done. Here, we'll just do it right here. So we'll get command, boom, set executor, new boom command. Then we'll go in our plugin.yml, commands, boom, description, boom. Okay, so just to recap here, the command is run, so it's going to be sent to this class here, this onCommand method, simple enough, but then we're going to get a protocol manager, and we're going to get the p.getLineOfSight, which hopefully should give us the block that the player is looking at. So this should run, and this should be the block that the player is looking at. So we'll get the location of that block, and then we're going to manufacture a new packet using the manager. We're going to specify the packet type, so packet type.play.server.explosion, explosion packet sent from the server to the client. And then we're going to set the packet data. So packet.getDoubles. It says floats in the documentation, but it's going to be a double for a location. So packet.getDoubles.write 0 for the first one, X, and then Y, and then Z. Simple enough, right? And then we're going to use the manager again to send the packet to that specific player. So hopefully it should do that. And let's go ahead and see on the server if it does it. But first, actually, let's go ahead and get rid of these listeners here because it's going to be spamming us. So we just want to avoid that. So we'll comment everything out. There we go. Reload. There we go. So now it's done spamming us, thankfully. But now, hopefully, if we do /boom, it should spawn an explosion. Let's look at this block here. Do /boom. And nothing happened. Let's see what we get here. No exceptions. Okay, that's a good sign, I guess. There we go. The explosion is so small, and it's within a block, so sometimes you can't see it. But it is there. If you look closely now, it depends on the angle, but of course we can edit the strength of the explosion by setting the strength field on the packet so we can make it look bigger. So let's try doing that. Remember on the documentation here it said that the strength, if it's bigger than 2, spawns a explosion emitter particle, which I believe is a bigger particle than the default explosion particle. So let's go ahead and try that. So this will actually, and this will be a float. So this will be the first float. And this will be the first float, so the index of 0 for the floats, because these were just doubles. So we can pretend that these are actually just doubles the whole time. So when we're trying to set the strength, we're going to set it as the first float, okay? Hopefully that makes sense. .getFloats, .write 0 for the first one, and then the strength. We'll just do 5.0. Remember, 2 or greater is the bigger particle. And of course it's, let's see. Yeah, so it says provide a double, but it's requiring a float, so we just put an F on the end. That marks it as a float. Okay, so now let's test this out on the server to see if a bigger explosion happens. Okay, back on the server, let's look at this block and do /boom. And look at that, we get a much bigger explosion particle because we did edit the strength. So that proves to you that you can manipulate the packet data to achieve different results. So that's pretty cool. So the whole concept of packets is really, really cool and powerful because even listening to packets is strong enough. You can do some really cool stuff with that. But manufacturing your own packets and artificially sending them to a destination like the client is also just so cool. You can do some really cool stuff. Now finally, let's edit the XYZ velocity data points on the packet so we can see how we can have the player be affected when the explosion happens to them. Because even though the player is not next to the explosion, because the explosion packet is being sent to the player, it's going to affect them no matter what. So even if you have the XYZ set to some amount, it's going to be the same every time because no matter what, the player is still receiving the explosion packet. Okay. Normally in Minecraft, we can assume that the packet is only going to be sent to the player if they're near the explosion, but in this case, we're artificially sending the packet, so we're not going to get the default functionality, of course. So for the player motion X, player motion Y, and player motion Z, these are floats, and I verified that these are floats. This would be the first index, this would be the second index, and this would be the third index, because the strength was the 0 index. And so these are the velocities of the player in each of those coordinate planes. So if we set the Y velocity to 2, this means that the player would go up by 2, whatever that 2 represents in terms of velocity. If we set it to X and Z, then the player would go in a diagonal motion in the X and the Y coordinate direction. So you can play around with these velocities here to make the player move in a certain direction and be affected by the explosion in different ways. What I want to do is just make it so that the player just goes up, so we can verify that it works. So we're going to do packet dot get float dot write 1, since it's the first one or the second one, and we're going to set this to 0 f packet dot get float dot write. This will be the Y one and the third index, or the third float, but the second index, and this will be we'll set it to 3. Okay, we'll see what that does to us. And then finally for the Z, get float dot write 3 0 as well. So since the X and the Z are 0, but the Y is 3, this means that they should only go upward. The velocity in the vertical direction is only affected by this. So when the player receives the explosion packet, they should see the explosion because we have set these values here at a certain location, but they should also experience a velocity in a certain direction depending on the data that we set. All right, let's test this out. So we're going to do /boom. Watch what happens. Look at that, we go upward. So even though, like I said before, we're not even near the explosion that much, we're going to go upwards by a velocity of 3. And you have to play around with these velocities to see how they affect you differently. Okay, pretty cool, right? Awesome. So yeah, now you know how to create your own packets and how to send them to players, or you can send them to all players. Hopefully you understand the main concept, which is, using the documentation to know which packets are which, and more importantly, how to read and write the data using the documentation, the tables that tell you, the fields of the data types, and what they do. So that's the most important concept. You just have to play around with it. And also you need to read other people's code if you get stuck on something. That's very helpful too. In the next episode of packets, I'll be showing you how to use packet wrappers, which simplify this process a lot. So if you want to see that, then make sure to hit that like button and I'll make a video on that immediately. Anyway, hopefully you enjoyed this. Packets are a very, very scary topic for beginners and just for people who have never worked with it before. Hopefully this explanation was very good because I hope to, when I make videos, I try to explain everything as best as I can. So hopefully this was a good explanation of how packets work and how to use them. If there's anything I can prove, then let me know. I would be happy to hear your criticism and all that. I plan on making some more advanced tutorials like this in the future, so stay tuned. Alright, so that's it for this video. Thanks for watching. In the description below, I'll leave a link to the code for this episode so you can check it out. You can bookmark it, come back to it later. If you forget any concepts or you just want to review the concepts I taught in this video, I'll mark everything up with comments so you can come back and read the code without having to rewatch the video, although your reviews are greatly appreciated. So yeah, I'll leave a link for that in the description below, so make sure to check it out. And another thing is I'll leave a link to our Discord server. It's a big community for programmers. You can ask for help on your programming projects if you're stuck on something, or maybe you can get some new friends. If you don't have any friends, there's lots of people here. It's growing really fast. You can find lots of people who are passionate about the same things as you. For example, if you like Minecraft Spigot development, you can find lots of people who like that. If you like C++, if you like Java, if you like web development, it's a really, really big programming community. So feel free to join. There's a link for that in the description below. And the last thing I want to tell you is that if you want to support this channel, you can click the join button below this video and you can join this channel as a member for as low as 99 cents a month, and you can cancel at any time. You get some cool perks like early access to all of my new videos, a cool rank on my Discord server like you see right here on the side, YouTube members, and also you get to see yourself on the screen like you see right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. And thank you. Thanks a lot. And that's it. So if you like this video, leave a like. If you want to see more, subscribe. And peace.